All right, welcome to the first lesson of Unit 2. And so Unit 2 is all about polynomials. And we've talked about a type of polynomial in Unit 1, which was a quadratic or a second-degree polynomial. And now we're going to extend our understanding to polynomials with higher degrees. So third degree, fourth degree, so on. And in this particular lesson, we're going to kind of connect some of the things that we ended Unit 1 talking about. So we're going to look at the graphic and algebraic representations of transformed polynomial functions. We did that with quadratics, transforming them, translations, reflections, so on and so forth. And we'll identify even and odd polynomial functions algebraically and graphically. So we're just going to extend that understanding now to working with higher degree polynomials. To get us started, we're going to rediscover, I guess you could say, the parent functions. You've seen these before in Algebra 1, and we talked about them briefly at the beginning of the unit, Unit 1. And so to help us get an understanding for what the parent functions are, you want to use the table of values to sketch the graphs of the parent functions, x squared, x cubed, x to the fourth, and x to the fifth. So to make this really clear, I've created the table for you, and so you just want to get this down in your notes and get this in your notes as well. So you'll plug in a value -3 into each of these functions. Right? So first, if you're working on x squared, you want to graph x squared, plug each of these x values into x squared, find the corresponding y values, and then plot those points. So we can do one together. If you plug in -3 for x, you're going to get that y is equal to -3 squared, which is 9. Now, just as an example, I'm going to plot this point here. And so this point correlates to the point -3, 9. And if you count by tens here, you'll notice 9 will be right about here. Now, I'm going to plot this point now, but what I want you to do is complete the entire table before you go through and plot the points, and maybe color code them. I'll do that as well, because you want to make sure that the graphs are accurate in relation to one another. So you don't want to go ahead and graph x squared and then realize that it makes it harder to graph x cubed because of where you placed, maybe 0.25 or whatever. So trust me, go through, fill out the entire table first, and then plot the points so that you can see where you're going to need to plot the other points in relation. Okay, so here you see the table filled out, and you'll notice why I had you fill out the table first. Realize that these values that have an absolute value less than 1, they get smaller and smaller the more times I multiply them by one another. And so you want to make sure that you are accurately portraying that, for example, x to the fifth, it has a lower value for -0.5 than will x cubed. And so you want to make sure that you are accurately displaying that. And so I want to show you what that will look like. And so here are the functions. I'll make it so you can see. Okay, and so you can take a look at how, for example, x to the fifth here. Notice that x to the fifth for values less than 1, in between 0 and 1, x to the fifth is actually the smallest. And then after 1, it's the greatest. And the same is true for the negative values, right? So for example, here's x to the fourth. X to the fourth is going to have a lesser value than x squared up until -1, and then it's going to eclipse it. Okay? So make sure that your graph accurately represents these, that you've labeled each one, and that you can always go back to this to take a look at how a second degree polynomial, third degree polynomial, fourth degree polynomial, and fifth degree polynomial will behave in general, because this is how they're going to look for the most part, with a few subtle changes. Now what is interesting to think about is how would you classify these functions? In other words, are some of them even, or some of them odd, and how would you know? You might want to go back and take a look at your notes. And in addition, how could we manipulate or transform these a little bit to make them slightly different? In other words, how would we apply some of the transformations that we learned back with quadratic functions to these polynomial functions? Because remember, they're still polynomial functions, and so hopefully we'll be able to implement the same maneuvers that we did and same transformations that we did previously with these. So now let's go ahead and quickly define what each of these, they each have a special name, and we'll talk about them and classify them as even, odd, or neither. All right, so here are the polynomial parent functions, and we've seen quadratics before. That's when the function has a highest degree of 2, and the parent function is obviously just x squared. We know we've seen transformations of these before. Cubic is x to the third, and this makes sense based on thinking about a cube. So a cube is in 3 dimensions, cubic to the third power. X to the fourth power is the parent function called a quartic parent function, is a 4th degree polynomial. And if your highest degree is 5th degree, you have a quintic function, and this is the quintic parent function. And so we want to have a nice space for us to write down some things that we observe about these. And if you've already observed which ones you think are even, which are odd, which are neither, that might be an interesting thing to jot down now. But for the rest of the lesson, what you're going to do is relate some of your understandings from transformations and from even and odd functions to take a look at some particular transformations of these parent functions and classify them, so that in class we can then talk briefly about it and look at some more complex situations and understand them a little more deeply. All right, so here are the problems for you to work on. So given the parent functions f of x, which is x squared, the quadratic parent function, and g of x, which is the cubic parent function, you're going to use your knowledge about transformations of quadratic functions to sketch the graph and name the transformation that occurred for each function below. So there are a couple things that you're doing. You're taking a look at the function, and for each function, a certain transformation has occurred. So notice that while some of them are applied to the quadratic, we're also applying the same idea to the cubic. And so you want to utilize what you've seen with quadratics to make the same transformation for the cubic polynomial, and so that you can sketch the graph. So notice that you have already sketched the graph of the parent functions, and so here you just have a transformation of these parent functions. So you're just translating, reflecting, whatever it may be for your particular function, and so you want to sketch a brief graph. You want to sketch a different graph for each of these, and so you should have 1, 2, 3, 4, 5, 6 different sketches. And for each one of these, by looking at the sketch, you want to determine whether it's an even, an odd, or a neither function. Okay? So for each of these, name the transformation that occurred, be specific, sketch a quick graph to show the transformation of the parent function, and then determine even, odd, or neither. Make sure you feel comfortable with your answers, use your notes from the previous unit, collaborate with other teammates, and we'll discuss on Monday.